Hello and welcome to another video. In this video we're going to be working on sequential digits. And in the problem, an integer has sequential digits only if each digit in the number is one more than the previous digit. Return a sorted list of all the integers in the range low to high inclusive that have sequential digits. So here they have an example. So if low is 100 and high is 300, it's 1, 2, 3, and 2, 3, 4. And then they have this other example where all digits are here. So the first thing to notice is, let's just say we had a range. Let's see how big the range can be. So the range can be anywhere from 10 to 10 to the 9th. So if we were to brute force this, if we just go through, like, let's say we got this range and we were just like, okay, let's just go through every digit, check if it's sequential. If it is, we'll put it in here. How would that work, right? So we'd have to get every number. So let's say we get like a number like this. We would have to go digit by digit and make sure that every digit is one bigger than the other one. So roughly this is going to be like a log n operation. And we'd have to go through every digit. So this is going to be something like n log n roughly. And even if we could get it, and even if we can get it over one time, like if we can get if the digit is sequential, it still wouldn't work because you have to go through too many digits. So that's kind of like the hint they give you is you can't like brute force your way through the digits. What you want to do is you want to actually compute the possible sequences and then just check if they're in the range. And notice, so for the possible sequences, I think it's reasonably simple to notice that, let's see, we make this bigger. So all the possible sequences are basically a subarray of this, right? Of this 1 through 9. So like, for example, here's like one sequence, here's another sequence, and so on, right? So how many total sequences are there? Well, it's going to be somewhere along the, like, how many contiguous subarrays are there of an array? It's roughly n squared, right? You say, like, pick a start index, and then for that start index, let's pick every single end index, and so on. So, for example, for 9, you would have 8 start indices. For 8, you would have 7. For, you know, so it would be like 9 times 9 plus, or actually, it would be 9 plus 8 plus 7 plus 6 plus 4 plus 5, and so on. So that would be roughly n squared. Now, realistically, it's not going to be exactly n squared. It'll be like n squared over 2, but roughly n squared. But the nice thing is n is only 9. So n squared is like 81. And over 2, there's actually only like 40 or so of these sequences. So as long as we can make a sequence like reasonably quickly, we can just get all the sequences, and then we can just check like which ones are in the range. And there's a bunch of ways to do this, but essentially the way I'm going to do it is every sequence is going to start with a number 1 through 9, right? So every sequence is going to start with 1 through 9. And what we're going to do is we're just going to start with every single one of these. So let's say we start with number 1. We're just going to have a current number, and we're just going to check, is our current number lower than the high? If it is, let's add another digit to the end. And then we can generate every sequence that has every number. So let's kind of walk through how this would work. So we'd start with a 1, right? We'd go 1 through 9. So we start with a 1. And then we say, okay, is 1 lower than the high? Yes, it is. Okay, well, what digit do we need to add to make it contiguous? And we're going to add to the right. We need to add a 2. And that's pretty easy to figure out, right? You just take the last digit and add 1 plus that digit. And if your last digit is 9, then you end because you can't have 1 past that. So we'll add a 2. Now we have 12. Is 12 less than the high? Yes, it is. So we can add another digit. What digit do we have to add? We have to add a 3. So we add a 3, and this is in the range now. So now we put it in the result. And then we add a 4. Is 4 lower than the high? No, it's out of range. So now we cancel that. Now we do the same thing with 2. Is 2 lower than the high? Yes. What digit do we need to add? We need to add a 3. Is this lower than the high? Yes. We need to add a 4. And this is in the range. And then we add a 5. And now it's not in the range, so you do the same thing with 3. Same kind of thing, right? So you start with 3, it's lower than the high. You put on a 4. Is this lower than the high? Yes, it is. Now this is not lower than the high, and we never had a number that was in the range. So we're done with that when we like do that, and so on and so on. So let's maybe do a couple numbers with this bigger thing just to demonstrate a little bit as well. So let's do this, like I said, a couple numbers for this second example. So we start with a 1. Is it lower than the high? Yes, it is. So we'll add another number. Lower than the high? Yes, it is. We'll add another number. Lower than the high? Yes, it is. Let's add another number. And now this is in the range. So we're going to put 1, 2, 3, 4 in the result. Now we put in a 5. And it's still in the range. So we're going to put in 1, 2, 3, 4, 5. Then we put on a 6. And now that's too big. So we get rid of this. Start with a 2. Maybe we'll just go through the 2s and call it there. So for 2, lower than the high, yes it is. Okay, we have to add a 3. Lower than the high, yes it is. Add to add a 4. Lower than the high, yes it is. Add a 5. This is now in the range. So 2, 3, 4, 5. So whenever we have a number, we just have to check, is it in the range? And it's always going to be lower than the high, unless we're going to stop the loop when that's not the case. But we just check, is it higher than the low as well? If it's lower than the high, or less than or equal to the high, and greater than or equal to the low, then we will add the number. So 2, 3, 4, 5, add another digit. Now this is bigger than the high. So we got 1 digit there. And let's do 3 and call it there. So 3, lower than the high, yes it is. Okay, we have to add a 4, lower than the high. Still lower than the high. And this is in the range. So 2, 3, 4, 5, 6. And now we add a 7, and now it's no longer in the range. And what's time complexity here? So we're going to start with every single digit, and we're going to build up all the way to 9. So like I said, it's basically going to be n squared, but n is only 9. So this is going to be actually an O of 1 time, right? And we're going to build numbers, but we're going to have a current number, so we're not going to have any space, so we'll have O1 time O1 space. There's a few ways to do this, but that's kind of like the main trick to this problem is realize you can't go through all the numbers. Instead, you can build all the consecutive sequences, and just for every single consecutive sequence, no matter how you start it, make sure that we have every single combination that is in the range. And yeah, so we can code that up. So we're going to have result, array, and we're going to loop for every number 1 through 9. So for I in range 1 through 9, we're going to have a current that's going to equal I. Then we just say while current is less than or equal to high. And then we're going to say if current is greater than or equal to low, then we should be putting it into our results. So result.append. And these are all going to be unique because our current number is going to start with every number 1 through 9, and we're going to always append like things to it. So these are all going to be unique. So we're going to append these. And then what we need to do is we need to figure out what's the last digit. And then we need to multiply everything by 10. So I guess that's the other thing I quickly sped up. I didn't really go through that. So let's say we have 1, 2, 3. How do we just put on a 4? So what we're going to do is we're going to take the last digit. Take the last digit, but just modding it by 10. Pretty easy. So we get a 3 here. We add 1. And then we take the rest of the number and we multiply by 10. So you get 1230. And now you add this last digit plus 1. So 1234. And then if the last digit is a 9, you can't add anything else, so we'll just have a break there. So if this was like something that ends with a 9, nothing can follow a 9, right? That's bigger than a 9. We can't have like 9, 10. It has to end with a 9 or less, so we can just stop there. So that's how you do that. Pretty easy. So we can say last digit equals cur mod 10 plus 1, right? We can take it, we can add 1 to get like the next bigger digit. Then we can say current equals current mod 10, or not mod 10, times 10, plus this last digit. And that's pretty much what we have to do. So now we'll get a new number, and then it's going to check again. Is it greater than low? If it is, append it, and so on. And then this will eventually break, and then we'll try the next starting digit. So we try every starting digit 1 to 9, and we keep building up our number until it's no longer in the range. Now you can make it a little bit more efficient, but because you know that there's only roughly 40 sequences, it doesn't really matter. Like you can cut it down from like 40 to 20, but this is already basically O of 1. So now, yeah. And now finally we just return result. Oh, now the other thing is these numbers won't be sorted. So for example here, let's say we have some big range. So we're going to put in like let's say our range is like 1 to 10 to the 9th. We're going to have like 1, 2, 1, 3, or not 1, 3, 1, 2, 3, and so on, right? But then we'll also have 2, and then 2, 3, and so on. So this won't be sorted, so we just have to sort it at the end. But because, like I said, there's only 40 numbers maximum, sorting it is still O of 1. So we just return it sorted. And yeah, that's basically it. So let's do that. And we have a problem. Oh, so what we forgot here is, so this is fine. But then if this last digit thing is if this last digit is a 9, like I said, then we need to break here. So we can just do that here. So we can say if last digit equals 9, we can break because there's nothing bigger than 9. I think that's our issue. Yeah, because we have 99 and then we put in 100. So then now we can just do this. We can add 1. And that should be correct, I think. Okay, there we go. So yeah, so that was our issue. Is the problem is like we had a 9, then we had 99, and then we got this 9 and added 1, but there's nothing like, or sorry, we wouldn't have 99, we would have 89, and then we would get this 9, and we can't add anything after the 9, like we can't add a 10. So that's our issue. So basically, like I said, this is O1 time and O1 space, because there's only, no matter how big your number is, this can be like whatever you want. There's only like 40 numbers that can be in this range. The biggest one being digits 1 through 9, right? So that's how we took advantage of not having to go through this, but actually building. And this is like reasonably common where you're given some huge range and you want to figure out like what are all the numbers in that range that satisfy something. Instead of going one by one for the numbers, you just calculate all the numbers that satisfy something and then just check how many of those are in the range. And a lot of those will be significantly faster. So yeah, that's going to be all for this one. And if you did like this one, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.